All right, so in this section, what we're going to do is kind of tie in a little bit of what we learned earlier with atoms and elements, for example, into really maybe the most useful tool that you'll find in any chemistry class and any science class, and that is the periodic table. So you can find periodic tables everywhere. You search online. This is the one that I will share with you as you take your quizzes and exams and stuff. So this is the one that you want to become familiar with. And I also have just a black and white version here as well. So let's review really quick before we get into some of the basics of the periodic table and remind ourselves, first of all, because the periodic table is of the elements, right? We talked about elements before. We looked at different types of matter. So as a reminder, we know that an element is an example of a pure substance, just like compounds are examples of pure substances, but an element is different in that it is a pure substance, meaning that the composition is the same throughout. And a pure substance that specifically now that is composed of one type of matter. So for example, if we have an example of whatever, now we have a bunch of these elements here on a periodic table. We can pick one. Let's just say carbon, for instance. Carbon is an element. The carbon then, based on this definition, would be made up of atoms. Well, they'll be made up composed of different atoms. Okay, and then we talked about the atom itself, the earlier sections. We know that atoms, that's the basic building block of matter, all matter is composed of atoms. And the atoms themselves are composed of even smaller things that we call subatomic particles. And we saw three of these. Remember, there's three different three. So we have our protons, the neutrons, and then we have the electrons. Protons abbreviated P, where P with the positive superscript, neutrons with N with a zero superscript, electrons with E, or E with a negative superscript. And then we also know some differences in terms of their masses. For instance, the proton has a mass of 1 atomic mass unit. Neutron has about the same mass. An electron has a negligible mass, meaning it's not zero, but it's close enough to zero that we can, for all intents and purposes, ignore it as a contribution to the mass of the entire atom. And then we also saw the locations of these subatomic particles. Protons are found in the nucleus, neutrons are found in the nucleus, and then your electrons are outside of the nucleus. Mm. And then the last thing, or one of the other things we mentioned was that overall, well, before we talk about overall, each of these subatomic particles has also a charge characteristic associated with them. So protons carry a positive charge, neutrons have no charge, they're neutral, and then electrons have a negative charge as well. So overall, when you look an atom by definition has to be neutral. If I referring to something as an atom, it has to be neutral overall. And because there are only two subatomic particles that contribute to charge, protons and electrons, if an atom is overall neutral, this means the number of protons must equal the number of electrons for. Okay, so we talked about all of this earlier on. So just a quick review. We're going to apply some of these things now to the periodic table of the elements, and we're going to take a much closer look now at what this entails, how it's organized, and then some of the characteristics, some of the things we can extract from a typical periodic table. So let's jump down to the one here, black and white. And the first thing that you will notice is that in this organization of the elements, you may think to yourself, well, first of all, who decided to organize the elements in this way? It doesn't look sort of intuitive, right? It's not like a square or a circle or anything like that. There's big chunks in different regions. Why is it organized that way? Well, the first thing we can take a look at in any periodic table entry, and we'll just use carbon again as our example, is you will see a typically 3 or 4 things in any entry. In your periodic table that you will get, there are 4 things that you'll see. So the first is the one in a dark bold color. Okay, so that's the symbol for the element. So that's the elemental symbol. And the elemental symbol is always it's either a single letter or it's 2 letters. The first letter is always uppercase, a capital letter. And if there is a second letter, it has to be lowercase. Okay, so for example, N is the symbol for nitrogen, and it's an uppercase, not lowercase. There's no lowercase N on the periodic table for as a symbol for the element. If you look at the one right next to it, so this is carbon. Carbon has the symbol big C, and it kind of makes sense when you look at not all of the elements, but for a lot of them, the symbol kind of corresponds to the first or the first couple letters of the elements. Well, if you go back a little bit on this periodic table, you'll see there's another element that also starts with C, and actually also starts with C and an A, just like carbon does. But you can't use the same symbol, obviously, because then if you say C for this element here, that means it's carbon, but it's not. This is actually calcium, and calcium is the symbol BC. So Ca, big C, small a is calcium. Big C is just carbon. Both of them start with a C and an A, right? But they're different things. Obviously, carbon is made up of carbon atoms, calcium made up of calcium atoms, etc. So that's the first thing to keep in mind with the elements, the symbols that are used, either 1 or 2 letter symbols. First letter is always uppercase. If there is a second letter, always lowercase. Usually the symbols correspond to the first couple letters of the name of the element. In some cases, they don't seem to make a whole lot of sense. All right, so for example, if you look down here at maybe a few of the precious metals, for instance, so down here we have silver. Okay, and you think about it just like with the 2 examples that we just did. If I were to ask you, I gave you the name silver, like what do you think the most probable elemental symbol for silver would be? You know, think, well, it starts with an S, so maybe S. Well, wait a minute, S is actually sulfur. Well, maybe it's Fi. Well, wait a minute, Fi is actually silicon, so it couldn't be anything. The symbol for silver is actually Kg, so big A, small g. And there is no A in silver, there's no G in silver in the name. Actually, the AG actually comes from a different language. And the name comes from argentum, and that's where the A and the G actually come from for silver. And you can maybe kind of guess there's a country called Argentina, And that's named after this name of the first silver because that's where they discovered a lot of silver in the country. So, um, and some of the symbols for the elements, the symbols don't match up necessarily with the name that we know, and that's because it came from a different language. In this case, it's Latin. And a lot of them are like that. Maybe in the case of tungsten down here, right? Tungsten has a symbol W. Obviously, there is no W in the word tungsten, but W comes from the German word for it, which is Wolfram. That's where the W comes from. So my point there is, in many cases, the symbols do match up with the names. In some cases, they don't, and that's usually because they come from a different language. So we have the periodic table of the elements. When we look at an entry, we're going to see several things. The first thing is going to be the symbol for the element. And then in our periodic table, there'll also be the name right under it. I would encourage you, as you see the periodic table, try to get familiar with it as much as you can. You do not need to memorize the periodic table. Okay, so don't waste your time memorizing it. You'll always get one. You just need to be able to interpret it, to find information from it, to extract relevant information. That's the most important thing. It's a tool. And you, just like in your line of work, you learn how to use tools. You need to know how to use the periodic table. All right, so we have N in this entry, N is nitrogen, and then you'll see two other numbers that are associated with the entry. And let's take a look at the first number, and that's the one on top here. And that's always going to be a whole number. And that number on top is known as the atomic number. And you will probably now see a trend as we compare atomic numbers across the periodic table. If, for example, if I look at the neighbors of nitrogen, which has atomic number 7, well, the neighbors to the left are actually increasing. So 5 and 6 for boron and carbon, nitrogen 7 and 8, 9, and 10. And then if I go all the way to the left side of the table, there's 11, 12, and as I go across, you'll see 13, 14, 15. So what you're probably noticing as you look closely at it is that that is actually how the elements are arranged. They are arranged by increasing atomic number, hydrogen atomic number 1, helium 2, and then so on and so forth. As you finish a row, you go to the second row, go from left to right and finish that row. You go to the third one, and so on and so forth. So the atomic number is actually how the elements are, the atomic number, like that when elements are arranged increasing. Okay, and if you follow it all the way down, you'll see that there's a total of 118 elements that we know of to this day. So what does the atomic number actually mean? What does that tell you? Well, the atomic number actually gives you the identity of that element. What I mean by that is if I tell you, oh, there's an element with atomic number 17, what element is it? Well, right away we know, if you look up 17 for the atomic number, right away we know that it's chlorine. So it identifies the element. Now, another important feature of the atomic number is that it also tells you the number of protons in that atom. So the atomic number is the number of protons. And remember that protons are in the nucleus. So again, if I tell you, you have this element with atomic number 17, what element is it? Well, it's going to be chlorine. We look it up. And if it's chlorine, we know that it has to have 17 protons. If your Cl would have atomic number 17, and it also has 17 protons. Now, if you remember from a few minutes ago, we also said that if we're dealing with atoms, the overall charge in an atom is neutral, and that means that the number of positive charges have to equal the number of negative charges. Protons have positive charges, electrons have negative charges. So if I know how many protons I have, I can easily figure out the number of electrons because they need to be the same so that they cancel each other out to end up with an overall charge of 0. If I'm looking at a chlorine atom, we'll also have 17 electrons. So I know right away, just by finding that element in the periodic table, if I have an atom of it, I know exactly how many protons are there. I just look at the atomic number. That atomic number also tells me the number of electrons that are there in that element, right? So that's how we interpret that periodic table entry, at least those first three things, the atomic number, the symbol, and the name. The last thing that we'll see in a periodic table entry is a number underneath that is usually a decimal number. I'll highlight that one in green, and that number is known as the atomic mass. So actually, let's do chlorine, focusing on chlorine. So for Cl, chlorine, we can look that up and we can say the atomic mass of chlorine. Sometimes it's called the atomic weight. They're used interchangeably. Atomic mass or atomic weight is for Cl is 35.45, and then if it's a mass or a weight, we need to have attach a unit to it. And when we talk about atomic masses or atomic weights, now remember, now we're thinking about really, really, really tiny things, right? Atoms. The unit that we use for atomic masses and atomic weights is the atomic mass unit, or AMU. So what this means is that if I were to look at chlorine, the average, on average, a chlorine atom would have a mass of 35.45 AMU. So we technically refer to that as the weighted. Takes into account how abundant the different forms of chlorine are in the environment, and then it averages all of that together to give you that average atomic. Like the weighted average mass of Cl 35.45 AMU, and you can see that for all of the elements on the periodic table. There's an atomic mass or atomic weight associated with every single one of those. Right. So those are what the entries on the periodic table will look like. We need to know what they mean, specifically in terms of the atomic number and the atomic weight. And then obviously the symbol for the element refers, the shorthand way to refer to the elements.